Hello students, today we are going to do chapter 3 from class 8, that is coal and petroleum. I have already covered the coal part. Today I will do the petroleum part. Petroleum. You know that petrol is used as a fuel in light automobiles such as motorcycles, scooters and cars. Heavy motor vehicles like trucks and tractors run on diesel. Petrol and diesel are obtained from a natural resource called petroleum. Petroleum is a byproduct of crude oil. Crude oil is the raw form of the oil which is found underneath the water. The word petroleum is derived from petra, that is rock, and oleum, that is oil, as it is mined from between the rocks under earth as shown in figure 3.4. See, this is the figure. Here it is given in the figure. This is the water. This is reservoir, that is sedimentary rock. The oil is above the water because it is lighter than water, and the gas is above the oil because the gas is even lighter than oil. So, crude oil. The oil we find underground is called the crude oil. Petroleum is the byproduct of the crude oil. Crude oil is a mixture of hydrocarbons from almost solid to gaseous form. These were produced when tiny plants and animals decayed under layers of sand and mud millions and millions of years ago. Crude oil is a naturally occurring liquid composed mostly of hydrogen and carbon. It is usually found underground but can also be found above ground in oil seeps and tar pits. Tiny marine plants and animals died and were buried on the ocean floor. Over time, the marine plants and animals were covered by layers of silt and sand. Over millions of years, the remains were buried deeper and deeper. The enormous heat and pressure turned the remains into oil and natural gas. Today we drill down through layers of sand, silt and rock to reach the rock formations that contain oil and natural gas deposits. So in absence of oxygen, conditions deposits has changed to kerosene. Kerosene is first, dead plants and animals undergo similar processes to become coal, which is deeply buried under high temperature conditions and transformed to gas and petroleum. The factor that determines the transformations is to gas or oil is the severity of the conditions which the organisms are buried in severe conditions. In smaller conditions, the hydrocarbon are produced, and in extreme cases, the methane, that is the natural gas, is produced. So the dead animals and plants were sank to the bottom of the ocean, buried under the sediments of the sand and mud and silt. Silt is the combination of soil and sand. It is the combination of sand and soil. You can say a fine clay. Okay. Layers increase in thickness with time. Temperature and pressure increases, causing the change of sedimentary rock. In absence of oxygen conditions, deposits are changed to kerosene. These marine plants and animals which are died and buried, they change into kerosene at the high temperature and pressure, and the kerosene is being pressed thermally and it degraded to oil and gas. This process takes hundred of millions of years. Crude oil is usually not runny enough or ignited easily enough for it to be useful. It is not easily ignited. We can't use it as a fuel. because it is not easily ignited, the different hydrocarbons it contains must be separated into simpler, more useful mixtures. To use the crude oil, we have to differentiate its hydrocarbons and separate it into simpler forms. Now let us talk about petroleum. We read here the word petroleum is derived from petra, that is rock, and oleum, that is oil, and it is mined from between the rocks under earth. Okay. Petroleum is a fossil fuel that is obtained by the decomposition of dead animals and plants due to geological changes under the earth. It means oil from the rocks. It is a dark oily liquid that is insoluble in water. Okay. Petroleum is a smelly oily liquid, usually quite thick. It is very thick. Its color ranges from greenish brown to black depending on where it is obtained. It is a complex mixture of hydrocarbons. Petroleum and natural gas were formed from very small sea animals and plants, that is, the example is plankton that lived hundreds of millions years ago. Petroleum is not burnt directly to supply energy. Petroleum must be treated or refined first. The process of separating hydrocarbons present in petroleum is in several parts, that is in several fractions, is called the refining of petroleum. Not only petroleum, most natural gas is burned directly as a fuel. Except petroleum, most natural gas is burned directly as a fuel. It burns with a clean blue flame, causing little pollution, which we use in cooking. At present, the petroleum which is used in today's world is 40%. We need the petroleum 40% for energy needs. It is a renewable resource. It is a non-renewable resource. So it is limited and it's being running out. The petroleum resources are running out. You know that petrol is used as a fuel in light automobiles such as motorcycles, scooters and cars. Heavy motor vehicles like trucks and tractors run on diesel. Petrol and diesel are obtained from a natural resource called petroleum. Okay. So here some motor cars, vehicles, they run on petrol and diesel, and some run on CNG, that is compressed natural gas. It is also a natural resource. See, this is the process from where the petroleum is being taken out. See, here it is oil and gas, it deposited under the water, under sand and silt rock. Okay, and this is the drilling machine by which the oil and the gas is being taken out. Oil well is being made to bring out the oil, and from here it is being refined. It is sent to refinery industries, and from the distribution industries, and from there it is been sent to retailing and end use, that is to after refining the petroleum, it is been sent to the gasoline places, that is petrol pumps, to sell. Petroleum reservoirs usually start with a formation pressure high enough to force crude oil into the well and sometimes to the surface through the tubing process. Sometimes the pumps are used, see here, the pumps are used at the bottom of the production tubing, that is operated by a motor or by the walking beam. Upstream activities involve exploring for crude oil deposits and the production of crude oil. Examples of firms that would belong in the upstream segment of the industry include companies that own rights to drill for oil and companies that provide support services to the drilling segment of the industry. Some industries get the right to drill and take out the oil, but not all the industries get the right to take out the oil. Some industries have got the right from the government of that country to take out the oil, to drill in the place and take out the oil. Midstream activities involve the distribution of crude oil to refiners, the refining of crude oil into sellable products, and the distribution of products to wholesalers and retailers. Examples of firms that would belong in the midstream segment of the industry include companies that transport oil by the pipeline, truck or barge, and companies that refine crude oil. Say, I have shown you the picture. In midstream, it is being sent to the refining industries and it is distributed to the refining industries. The crude oil is being distributed and to the refining industries. After it is been refined, the byproducts, that is kerosene, petrol, naphtha, the byproducts are being distributed to the wholesalers and retailers, and these are all the in this also all the companies don't have the right to take the byproducts of the crude oil. Some industries have the right to get the byproducts which is been refined, and it is distributed to that companies, and that companies will take it from either from pipeline or by the truck, and they will in downstream activities involve the retail sale of petroleum products. Gasoline stations are perhaps the most visible downstream companies, but companies that deliver heating oil or propane would also fall into this category. That is, after it has been distributed to the wholesalers and retailers, the wholesalers will sell it to the retailers and the retailers will send it to the gasoline stations, that is the petrol pumps, but some companies that deliver heating oil or propane would also fall into this category. Propane is also the byproduct of the crude oil, and it is also, and the heating oil that is kerosene, gas oil, is also been delivered to some companies which has got the right, and they sell it to the people. Now, refining of petroleum. The process of separating the different constituents of fractions of petroleum is known as petroleum refining. Petroleum refining involves fractionating crude oil into major fractions through chemical, thermal, and physical separation processes. These fractions are further processed and converted into over 2,500 finished petroleum products, that is byproducts. Refineries separate crude oil into smaller fractions to produce fuels like gasoline and diesel, as well as non-fuel products and raw materials for the chemical industry. Major refining stages include distillation, conversion or upgrading, and desulfurization. Distillation, the first stage in the crude processing, is known as distillation or fractionation. In this process, the crude oil, which is mixture of many hydrocarbons, is boiled and recondensed to separate the crude oil into components based on ranges of boiling points. What is distillation? First, let me tell you about simple distillation. When the mixture of two liquids are heated to form vapor and then cooling that vapor to get a liquid is called simple distillation. Distillation is used to purify a liquid by separating the components of a liquid mixture. Simple distillation is done with the two liquids. It's a mixture of two liquids only. And in case of 3 or 4 liquid mix have a very high boiling points, that is crude oil, then we will use fractional distillation. Crude oil is a mixture of different hydrocarbons. The substance with the lowest boiling point will condense at the highest column, as the column is coolest at the top, and substances with higher boiling point will condense in the lowest column. Smaller molecules condense higher up the column. Very heavy components which are unable to boil will leave from the bottom of the column in a stream known as residue, while very light components will leave from the top of the column. This stream is known as liquefied petroleum gas, that is LPG, which is used in every home in India for cooking. See, now I will show you the fractional distillation through this image. Okay. The crude oil is fed into the tower. See, from here the crude oil is fed. The crude oil is fed into the tower. Here is the heater. Here, see, here is the heater. The crude oil is heated until it all turns to gas. Okay. This is the furnace. It is been transferring through furnace to the tower. Yeah. The hot gases enter at the bottom of the tower. From here the hot gases are entering. Okay. The vapors pass up the tower. After heating up, the vapors are passing up from here. As they are traveling up, they are cooling down. They get evaporated depending on the temperature. See, here the temperatures are given. See, the compounds in the liquid petroleum, it has very low boiling points and they don't turn back to the liquid state. It has very fewer molecules, carbon atoms. See here, it is 20 degrees Celsius. It is burning at 20 degrees Celsius. It contains 1 to 4 carbon atoms. It is used as fuel, used for petrochemicals. It is odorless and it contains methyl marpentane. It has methyl marpentane. It is false. It has a false smell, so that we can get the smell of the gas, that is LPG, to avoid the fire. Example is LPG and PNG. The molecules are smaller. The bitumen fraction contains the largest molecules and they have the highest boiling points. Here it is here. It has the largest molecules and they have the highest boiling points. They turn back to liquid first. It is the dense liquid left after distillation. It contains the carbon atoms are 21 to 40 and it is used to make roads. It is used in construction of roads. See, from here the lubricating oil is coming out. The molecules in the lubricating oil fraction are not as large as those in the bitumen fraction, so condense further up the tower. It is burnt at 300 degrees Celsius. The carbon atoms present in lubricating oil is above 613. It is burnt at 613 Kelvin and 300 degrees Celsius. The carbon atoms which lubricating oil contains are from 16 to 20. It is used in preparation of wax, oil for cars and other machines. As the remaining vapor cools, further fractions are collected. The lower their boiling point, the further up the compounds go. See here, the diesel is burnt at 260 degrees Celsius. The lower their boiling point, the further up the compounds go. See, diesel contains 15 to 18 carbon molecules. It is used in fuel preparation of naphtha, diesel engines. See, the lower their boiling point, the further up the compounds go. The remaining vapor cools. Further reactions are collected. Here the kerosene is collected at 180 degrees Celsius. Kerosene contains 12 to 15 carbon molecules. It is used as fuel for lamp, stove, jet fuel, paraffin for heating and lighting. See here, naphtha is burnt as 120 degrees Celsius. It is used to make chemicals. Naphtha contains 5 to 6 carbon atoms. It is also used as a solvent in the manufacture of adhesives. See, now petrol is been formed at 70 degrees Celsius. It contains 5 to 12 carbon atoms. It is used for fuel for aeroplane, and it is also used in cars. Now see here, the refinery gas, that is petroleum gas. The compounds in the liquid petroleum gas fraction have very low boiling points and don't turn back to the liquid state. See here, it is burnt at 20 degrees Celsius. It contains 1 to 4 carbon atoms. It is used as a fuel. It is used for a petrochemical industries. It is odorless gas, so the methyl mercaptan is used. It is used for a foul smell, to add the foul smell. The molecules of the refinery gas are smaller. Molecules require less oxygen to burn properly. The more carbon atoms there are, the more oxygen we need. So here we saw the gases condense at the top of the column, the liquids in the middle, and the solids stay at the bottom. Hydrocarbons with small molecules make better fuels than hydrocarbons with large molecules because they are volatile, flow easily, and are easily ignited. Natural gas. Natural gas is a very important fossil fuel that is stored under high pressure and is easy to transport through pipes and referred to as CNG, compressed natural gas. It is a non-polluting fuel. It helps in the manufacture of a number of chemicals and fertilizers. So natural gas is a mixture of hydrocarbons in the gas state. Methane, the main hydrocarbon is in natural gas, is useful for cooking. Several different liquid fuels can be obtained from crude oil, including petrol and diesel oil for vehicles and kerosene for aircraft. These fossil fuels, that is the crude oil and natural gas, they are non-renewable and they are being used up faster than they are being formed. If we carry on using these fuels, they will run out one day. The gaseous mixture of lower hydrocarbons which occurs deep inside the earth, either alone or covering the crude oil in an oil field, is called natural gas. Natural gas mainly consists of methane. Natural gas is an ideal fuel. It burns with a blue smokeless flame. It does not leave ash after burning. It has a high calorific value, that is about 55 kg per gram. It has a high calorific value, about 55 kilojoule per gram. Natural gas can be used as a domestic and industrial fuel for obtaining hydrogen on industrial scale, for manufacturing carbon black. Carbon black is used in rubber industry. As the raw material for manufacturing petrochemicals and fertilizers, also the natural gas is used. Natural gas can be compressed under high pressure to obtain compressed natural gas. The CNG can be easily transported through pipelines. CNG is now being used as a fuel for automobiles, that is cars, buses, scooters, etc. On burning, CNG does not produce any smoke. Its products on burning are carbon dioxide and water. It leaves no ash on burning. Therefore, CNG is a clean gas. So students, now today I have also covered the petroleum part. If you have any difficulty, please comment me in the comment box. Thank you.